Alright, so now we'll do graphing of a parabola using its vertex form of equation. So let's have this example: y is equal to negative 1 over 12 times x minus 3 quantity squared minus 5. So with the vertex form of this parabola, it actually gives us a vertical parabola, so it's either opening up or down. But with the value of our coefficient a right here, it's negative, therefore our vertical parabola is opening downward. And the next important thing that we need to identify in graphing a parabola is the distance p, which is given as 1 over 4 times the absolute value of a. So let's solve for it. 1 over 4 times the absolute value of negative 1 over 12. Right, so that is actually 1 over 4 times 1 over 12, and 4 times 1 over 12, it gives us 1/3 right here. 1 divided by 1/3 is actually 3, so our distance p is 3. Alright, so take note of this table right here, because this gives us the parts of the parabola, this information about the parabola, and we can easily identify the parts of the parabola as we use the formulas in here, and that could actually guide us in graphing the parabola. Alright, so from the table we've shown earlier, we could easily have the formulas that we could use in identifying the parts of a parabola, and we already know that this parabola is a vertical parabola and it opens downward. Our distance p is 3. So to identify the other parts, let's have the vertex. We know that the vertex form of the equation is in the form y is equal to a times x minus h quantity squared plus k. So our vertex is simply h comma k, so we get it from the equation. Our h is 3 and our k is negative 5. So our vertex is 3 comma negative 5. Notice that even if this is negative 3 inside the parenthesis, in the vertex we change the sign of this number inside the parenthesis, thus it becomes positive right here. Now for the focus, our formula is given as h comma k minus p, knowing that the parabola is opening downward. So copy the h, that is 3, and then our k is negative 5, and then minus p, so negative 5 minus 3 is negative 8. So our focus is 3 comma negative 8. For the endpoints of the lattice rectum, the formula that we're going to use is h plus n minus 2p comma k minus p. This k minus p we already know is negative 8, so simply copy that in here. What we need to get is the x-coordinate, and the x-coordinate is given as h plus n minus 2p. So our h is 3, 2p is 6, so let's do the addition first. 3 plus 6 is 9, and then 3 minus 6 is negative 3. So the endpoints of our lattice rectum would be 9 comma negative 8 and negative 3 comma negative 8. Then for the axis of symmetry, since we have a vertical parabola, our axis of symmetry is given as x equals h. We know our h is 3, so our axis of symmetry is simply x equal to 3. So it is going to be a vertical line intersecting the x-axis. And for the directrix, since we have a downward parabola, the formula for the directrix is y equals to k plus p. So our k is negative 5 and our p is 3. So negative 5 plus 3 is negative 2. So our directrix is y equal to negative 2. And this is going to be a horizontal line intersecting the y-axis. Alright, so now as soon as we're able to get all the necessary information that we need in graphing the parabola, let's now plot these points and draw these lines and start graphing the parabola. So the vertex is 3 comma negative 5. We already have an idea. Take note that our parabola is going to open downward. So our vertex is at 3 comma negative 5, so that will be right here. Okay, and then our focus is 3 comma negative 8, so it's going to be down here. because we know our parabola is opening downwards, so our focus is going to be below the vertex. So let's plot that one. So 3, negative 8. So it's negative 5, negative 6, negative 7, negative 8. So our focus is right here. Vertex and then the focus. And then let's have the endpoints of the lattice rectum. Take note that the distance of the focus from the vertex is the distance p, and the length of the lattice rectum is actually 4 times p. Okay, so the entire width of the lattice rectum will be 4 times the distance of the vertex from the focus. But we know that a parabola is symmetrical, so if this length is 4p, meaning this has to be 2p and this has to be 2p, so we could draw the symmetrical parabola. So that's why we're going to have these 2 points right here. So these are 9, negative 8. So 3, 6, 9, negative 8. So as you can see, the endpoints of the lattice rectum are actually parallel to the focus. Okay, so you plot the points, the endpoints of the lattice rectum parallel to the focus, not parallel to the vertex. Okay, so the other point is negative 3, negative 8. So negative 3, and then go to negative 8. So it's right here. Okay, all right. So now we have already plotted the endpoints of our lattice rectum, so we could now have an idea that our parabola will look like that. So let's now connect the vertex to the endpoints of the lattice rectum to graph the parabola. So from the vertex, connect to the endpoint. So take note that the graph of a parabola is a curve. Okay, then next let's draw the line, the axis of symmetry. So our axis of symmetry is x equals 3, so it must be a line passing through the x-axis at the coordinate 3. So this is the coordinate 3 on the x-axis. Let's draw a line passing through it. And as we can see, the axis of symmetry is actually a line passing through the vertex and the focus of a parabola. And then for the directrix, our directrix is y equal to negative 2. So let's go to the y-axis and then draw a line passing through the coordinate negative 2. So it's right here. Okay, so that is our directrix. As we can see, the vertex, the distance of the vertex from the focus is just the same as the distance of the directrix from the vertex. So this is the graph of our parabola, y equal to negative 1 over 12 times x minus 3 quantity squared minus 5. Alright, so let's have another example. Let's now graph x equal to negative 1/4 times y plus 4 quantity squared. And then from the vertex form of the equation, we could easily identify that it is a horizontal parabola, and since the coefficient a is negative, therefore it is opening to the left. The next important information that we need to solve is the distance p. So solving for the distance p, it's going to be 1 over 4 times the absolute value of negative 1/4. So that is 1 over 4 times 1/4. So 4 times 1/4 is 1. 1 divided by 1 is 1. So our distance p is equal to 1. Then for the vertex, we know that the vertex is h, k. However, unlike the vertical parabola, it's not like hk. With horizontal parabola, it's going to be h right here and then k inside the parenthesis. So obviously in the equation that is given to us, we have no h, so our h is 0. And the k is going to be negative 4 because it's y plus 4 inside here. So if this is positive inside, in the vertex, we have to change the sign, so it's going to be negative 4. Now for the focus and for the rest of the information we need for the parabola, we'll still use the table shown earlier for the formulas. And then for the focus, the formula is going to be h minus p, k because it's a leftward parabola. And then our h is 0, our p is 1, so 0 minus 1 is negative 1, and then copy the k, so that will give us negative 4. And then for the endpoints of the lattice rectum, the formula is h minus p, comma, k plus and minus 2p. So h minus p, we already know the value, it's negative 1. So let's copy the negative 1 for the two endpoints. And then for the k plus 2p, 2p is 2 times 1, right? So this is 2. So our k is negative 4. Negative 4 plus 2 will give us negative 2. And negative 4 minus 2 will give us negative 6. So the endpoints of our lattice rectum are negative 1, negative 2, and negative 1, negative 6. And then for the axis of symmetry, our axis of symmetry, since it is a horizontal parabola, instead of x equals h, our axis of symmetry is y equals k. So that is going to be y equal to negative 4 for this parabola. And then for the equation of the directrix, the formula is given as x equal to h plus p. So our h again is 0, and then plus p, so 0 plus 1, it's going to be 1. So our directrix is x equals 1. So let's plot these points and then draw the lines to graph this parabola. Alright, so now let's start graphing. First, let's plot the vertex, which is 0, negative 4. So it's going to be right here. Alright, and then let's plot focus, and it's negative 1, negative 4. So it's right here. As you can see, the focus is at the left side of the vertex because we have a parabola that is opening to the left. Alright? And then the lattice rectum, the endpoints of the lattice rectum are negative 1, negative 2. So we have it here. And the other one is negative 1, negative 6. So it's right here. Alright? And then let's graph the parabola by connecting the vertex and the endpoints of the lattice rectum. So make it a curve. Oops. And then next, let's draw the line, axis of symmetry, which is y equal to negative 4. So it will be passing through the y-axis at negative 4, and we know that since it is the axis of symmetry, it's going to pass through the vertex and the focus, and it's going to divide the parabola into symmetrical parts. So it's going to be here. Alright, and then for the directrix, we know that the directrix is going to be opposite the opening of the parabola, and it's going to have the same distance as the focus from the vertex. So our directrix is x equal to 1. So let's go to the x-axis at the coordinate 1. So it's right here. So let's draw the line, and there we have it. This is now the graph of our parabola, x equal to negative 1/4 times y plus 4 squared.